When we take two number lines, put one horizontal, and put another one vertical, what we get is called the coordinate plane. The horizontal number line here we call the x-axis, and the vertical one we call the y-axis. Where these two lines intersect, we call the origin, and this is the point 0, 0. So that anything to the right of this point along the x-axis are our positive numbers, 1, 2, 3, 4, and any fraction and decimals that are in between there. Anything to the left will be our negative numbers, -1, -2, -3, -4. Same thing goes along the y-axis. As I move upwards, these are our positive numbers, 1, 2, 3, 4. And as we go down, these are our negative numbers, -1, -2, -3, -4, etc., etc. By intersecting these two number lines, we also split the coordinate plane into 4 sections. We call these quadrants. So the top right section is all of our positive numbers, and we call this quadrant 1. Then we move to the left, and this is considered quadrant 2. Below that is quadrant 3, and to the right of that is quadrant 4. To plot a point on the coordinate plane, I need two things. I need to know its horizontal distance from the origin and its vertical distance from the origin. So these are a list of points, and we are going to plot them on the coordinate grid. So point A, I'm going to start at the origin. I'm going to go back 2, that's the horizontal distance, and down 4. So point A is right here. I'm going to put a dot where point A should be, and near that dot I'm going to label it A. Point B, again I start at the origin. I'm going to go over 4, down 2. So point B is right here. Remember, horizontal, left, right first, then up and down. Point C, I'm going to start at the origin and go over 3. I don't have to go up or down at all. So point C lies on the x-axis. Point D, I start at the origin. I'm going left or right 0, but down 2. So here is point D. If I go back and look at what quadrant these points are in, A is in quadrant 3. B is in quadrant 4. C lies on the boundary between two quadrants. So we would say that C is not in a quadrant, instead it's on the x-axis. Same thing goes for point D. It's not in a specific quadrant, it lies on the axis. And in this case, point D is on the y. In the next few sections of this chapter, we're going to be dealing with graphing equations that are lines. And these equations have this general form: ax plus by equals c. A, b, and c are just numbers. They could be positive, they could be negative, but they're just numbers. So for example, the last equation that we just graphed, x plus y equals 6, in this equation a is 1, b is 1, and c is 6. 2x minus 3y equals 12. This is another linear equation where a is 2, b is -3, and c is 12. X minus 6y equals 15 is another linear equation. All of these linear equations are in what is called standard form. So let's talk about how to graph equations that are in We're going to graph the linear equation x minus y equals 10. To do that, we want to find the intercepts. Intercepts of a graph are where the graph touches or intercepts the x and y axis. To figure out where the intercepts are, we are going to plug in values for x and y. Those values are 0. When x is 0, you are on the y-axis. When y is 0, you are on the x-axis. So that's what makes the intercepts so important to us. They're also very easy values to plug in. If I plug in 0 for x, I get the equation 0 minus y equals 10. Well, what is the value for y? Negative 10. If I plug in 0 for y, I get the equation x minus 0 equals 10. Well, what is the value for x then? 10. So let's graph these 2 points. 0, 10 is way back here. 1, 2, nope, I lied. 0, 10 is down here. 0 for x, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right at the bottom here. Can't even see it. Okay, 10, 0 is way over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this graph is the line right here. To graph the equation 2x plus y equals 6, I'm going to plug 0 in for x and 0 in for y and find their intercepts. If I plug 0 in for x, y must be 6. So I'm going to plot the point 0, 6. 1, 2, 3, 4, 5, 6. If I plug 0 in for y, I get the equation 2x equals 6. X must be 3 then. 1, 2, 3. Here is the graph of the line 2x plus y equals 6. To graph the equation x over 2 equals y over 3, I'm not even going to rewrite it in standard form. I'm going to jump right into finding the intercepts. Okay? To find the x-intercept, that means I'm on the x-axis, I'm going to plug 0 in for y. If y is 0, I get the equation x over 2 equals 0 over 3. When I solve that equation for x, I find that x is 0. So when y is 0, x is 0, and that means this graph goes through the origin. When I do the same work to find the y-intercept, that means I'm going to plug 0 in for x. I'm going to get the equation 0 over 2 equals y over 3. And when I do the work to figure out what y is, I get that y is 0. So the x and the y-intercept are both 0. That means it goes through the origin. I need another point to graph this line. If I look at my equation, I'm going to try to pick a nice value for x or a nice value for y that would be easy to solve for. So I'm going to pick that x equals 2. Because if x equals 2, 2 over 2 is 1. I don't have a fraction over there. So 2 over 2 equals y over 3. And if I cross multiply solve, I'm going to get that 2y equals 6. So y must be 3. So this graph also goes to point 2, 3. To graph the equation y equals 2x plus 5, I'm first going to rewrite it in standard form. I'm going to subtract 2x from both sides and rewrite the equation to be negative 2x plus y equals 5. Next, I'm going to find the intercepts. The x-intercept of this equation is found when y is 0. So I'm going to make y equal to 0. And I get the equation negative 2x equals 5. Well, to solve for x, I divide by negative 2, and I get that x is negative 2.5. So let's graph that on our line. 2 and 1/2. I'm right in between the two marks there. To figure out the y-intercept of this line, I'm going to plug 0 in for x. If x is 0, I get the equation y equals 5. Whoop, I'm done. Y is 5. 1, 2, 3, 4, 5. So I get this point right here. Connect these two with a line, and there's the graph of this equation. To graph the equation x equals -2 on the coordinate grid, I usually want to try to find the intercepts of this equation, but this is difficult because I'm missing a y. I'm going to try another technique, and that is just to create a list of values for x and y and plot them to find my line. Well, the equation x equals 2 means that no matter what I pick, x has to be 2. So I'm going to pick 3 values, and x has to be -2. So if x is -2, what's y? Well, that's a nice thing. Y could be anything. I don't care about y as long as x is -2. So we can graph the point -2, 0, or -2, 1, or -2, 2. That means my line is a vertical. To graph the equation y equals 4, I'm going to use the same technique as I used in the last video. I can't find intercepts, so I'm just going to try to find a set of ordered pairs x and y that work in that equation. Well, my equation tells me that y has to be 4. So that makes my choices easy for y. And that means, well, if y has to be 4, x could be anything. I'm going to pick 0, 1, and 2. When I graph these points, 0, 4, 1, 4, and 2, 4, I see that the graph of this equation is the horizontal line up at y, or that has all the y values of 4.